In this video, we're going to look at some examples of how you'll be asked to use the cofunction identities. So one type of problem you'll be given one of the 6 trig ratios. And in this problem, I've given you that the sine of theta is 5/6, and you'll be asked to find other trig ratios. So notice that we're finding cosine, tangent, cosecant, secant, and cotangent. These are all your main 6 trig ratios. But now we're also finding your cofunction ratios using your cofunction identities. So I have those identities right here at the top of the screen so that we can refer back to them. All right, so the first thing that you want to do to get started is draw a right triangle and label the 2 sides that you know. Go ahead and put your theta wherever you want it to be, as long as it's not in the place of the right angle. So I'm going to put my theta here. All right, we're given the sine is 5/6. Remember, sine is opposite over hypotenuse. So that means my opposite side has to be 5 and my hypotenuse has to be 6. So from where my theta is, I'm going to go opposite, which means across the triangle, and put my 5. And then hypotenuse is always across from the right angle, and so I'm going to put 6 there. So in order to find these things, we need to find the third side of our triangle. So we're going to have to do the Pythagorean theorem, and we're missing a leg, so it's going to be 5 squared plus, I'll just put x squared equals 6 squared. So we have 25 plus x squared equals 36. We want to get x by itself, so we're going to subtract that 25 over. So we get x squared equals 11, and then square root both sides. And so x is the square root of 11. 11 does not have a good whole number square root, and it also doesn't branch out, so we're just going to leave it as the square root of 11. So we'll put that side here. All right, so let's fill in our other 5 basic trig ratios first. We know that cosine is adjacent over hypotenuse. So from where our theta is, the adjacent side is square root 11, and the hypotenuse again is 6. Tangent is opposite over adjacent. So from our theta, our opposite side is 5. Our adjacent side is square root 11, so we have 5 over square root 11. Remember, we can't leave a square root in the denominator of our fraction, so we're going to rationalize that out. So we actually get 5 square root 11 over 11 as our answer there. All right, cosecant is just the reciprocal of sine. So there's 2 ways you can do this. If you know that sine is opposite over hypotenuse, you can flip that, which would be hypotenuse over opposite. So you could go back down to your triangle and you could put your hypotenuse side over your opposite side, which would be 6 over 5. Or, since we were already given sine to begin with, we can just flip that. And so 6/5 is our cosecant. Secant's the same way. Secant and cosine are reciprocals. So we can just flip cosine, or if you'd prefer to come back to the triangle and remember that cosine was adjacent over hypotenuse, so we need hypotenuse over adjacent, which would be 6 over square root 11. And we can't have square root 11 on the bottom, so rationalize that, which will be 6 square root 11 on the top, and then just 11 on the bottom. And cotangent. If tangent's opposite over adjacent, cotangent is adjacent over opposite. So if you're looking at your triangle and you're looking at adjacent over opposite, that would be square root 11 over 5. Or if you just want to flip tangent, that's fine as well. Be careful when you flip tangent that you always flip the simplest one. For example, if I flipped this, my final answer, that would put a square root 11. It would put a radical back in the denominator of my problem, which means I would have to rationalize it again. So it's not always the final answer that I want to flip. Sometimes I want to go back to the simpler version, which would have been 5 over square root 11, and flip that, which puts my radical back in the numerator, which is what I want. Okay, so now that you have your 6 basic trig ratios, now we want to find the trig ratios for the complement of whatever theta is. Remember, theta is unknown. Theta could be any angle smaller than 90. So now we're going to find our complements. So if we're wanting the sine of 90 minus theta, if you look at your identities, the sine of 90 minus theta is the same as whatever the cosine of theta was. We've already found the cosine of theta right here as square root 11 over 6. So that's our answer. Now we want the cosine of 90 minus theta. The cosine of 90 minus theta is whatever the sine of theta was. The sine of theta was given to us as 5/6. So that's our answer there. The tangent of 90 minus theta is right here. The tangent of 90 minus theta is equal to whatever the cotangent of theta was. The cotangent of theta we found to be square root 11 over 5. So as you can see, what we're finding over here is pretty simple because all of these answers are going to come from the answers that we already have. We just have to know which one gets paired with which. Cosecant of 90 minus theta is here. That gets paired with secant of theta. Secant of theta was here. We found that to be 6 square root 11 over 11. Secant of 90 minus theta gets paired with cosecant of theta. Cosecant of theta was 6/5, so secant of 90 minus theta is 6/5. And then the cotangent of 90 minus theta is here, and that gets paired with whatever the tangent of theta was. The tangent of theta we found to be 5 square root 11 over 11. And so now you found everything you need using your identities. Let's do one more example of this. Okay, for this problem, we're given that the cotangent of theta is 13 over 7. So let's draw what we know so far. Draw your right triangle. And we know that tangent's opposite over adjacent, so that means cotangent has to be adjacent over opposite. So wherever you put your theta, make sure your adjacent side is 13, and your opposite side, which is directly across the triangle, is 7. Okay, now in this problem, we're missing the hypotenuse. So let's do the Pythagorean theorem. 7 squared plus 13 squared equals the hypotenuse squared. 7 squared is 49. 13 squared is 169. And then if we add 49 and 169, we get 218. And then we want to square root both sides. Now, 218 doesn't have a nice whole number square root, but it will branch out. That's an even number, so we can branch 218 into 2 times 109. But 109 is prime, which means it's not going to branch any further. So we'll just leave our answer as the square root of 218. Okay, so now let's start to find our ratios. Sine is opposite over hypotenuse. So from where our theta is, our opposite side is 7. Our hypotenuse is square root 218. We can't have that, so we're going to multiply the top and the bottom by square root 218, which is going to give us 7 square root 218 over 218. Cosine is adjacent over hypotenuse. So our adjacent side is 13, hypotenuse square root 218, and then we're going to rationalize that one as well. Okay, tangent, opposite over adjacent. So if we look at our triangle, our opposite is 7, our adjacent is 13, so it's 7/13, or we could have just got that from flipping the cotangent that we were originally given. Cosecant, remember, is the reciprocal of sine, so we just need to flip our sine ratio. I don't want to flip this because if I flip that one, that puts my radical back in the denominator. So I want to go back to a simpler version, which is this one, and flip that one. If I flip that one, that puts the square root of 218 on top, and it puts the 7 on the bottom, and we don't have to rationalize. The same thing with secant. Secant's the reciprocal of cosine, but rather than flipping this one, I'm going to go back and flip this one, which is square root 218 over 13. So my radical doesn't end up in the denominator. All right, so now we're ready to use our cofunction identities to pair up one of these answers with one of these. Notice here, instead of 90 degrees minus theta, I have pi halves minus theta, just to get you used to seeing those in radians as well. Pi halves radians and 90 degrees are the same thing. So the sine of pi halves minus theta gets paired with the cosine of theta. And our cosine was 13 square root 218 over 218. The cosine of pi halves minus theta gets paired with the sine of theta. So our answer will be 7 square root 218 over 218. The tangent of pi halves minus theta gets paired with the cotangent of theta, which was given to us, 13/7. The cosecant of 90 minus theta is equal to the secant of theta, so square root 218 over 13. The secant of pi halves minus theta would pair up with cosecant theta, which was square root 218 over 7. And the cotangent of pi halves minus theta is going to pair up with the tangent of theta, which was 7/13. In this case, we didn't have a number that broke down, but if we did have a number that broke down, always make sure your fractions are reduced. For example, right here, if 7 and 218 would reduce, I would need to reduce that. Same thing here. 13 and 218, if that would reduce, then you always want to reduce as far as you can.